Hello, everyone. I'm Xavier Me. As Ricard said, I broke my knee playing football. So that's what happens when you are almost 40 and you keep playing football. So I'm not going to move really much around the stage. So I'm going to talk about how we manage security automation in Skyscanner and what challenges that pose to the security team. So I'm going to introduce myself really quick. First, I'm Xavier Me. I joined Skyscanner like 10 months ago. You will think that that's not much time ago, but surprisingly, I've been in the security team like from almost the beginning, so we are quite a new team in the company. So before that, I was living in Chile. I was doing freelancing for a little bit. Before that, I was living in London. I worked in Verizon and Skyscanner. And this is my GitHub page and Twitter account. Okay, so a bit of how Skyscanner organization is. So we have tribe and squads. A tribe is formed by several squads. A squad is like an autonomous team formed by like 8 or less people. So the key things about this model is that squad has a clear goal and aligned with the mission of the tribe. And it embraces like squad act independently from each other, although they collaborate, but the idea is that they have like they work quite independently from each other. So there is like a decentralized decision making. So you have the chapter and guilds. This is like this kind of is the squad collaboration. A chapter is squads collaborating in the same tribe. This is because you have some guys with real expertise in something, like, I don't know, Docker or something like that, and even that they work in a different squad, they gather together from time to time and they do stuff to improve the company. And the guild is kind of the same concept, but between different tribes. So that's more people interested about same things like, I don't know, web or things like that, or Kubernetes or the pipeline. So they also have these regular meetings, and they also collaborate and get some ideas on how to improve the company. But there is a video on YouTube about how this tribe squad model works. So what this means for engineers. So Skyscanner is a strong lean organization. What that means is that there is a strong bias towards getting things done really quick and give value to the customer early. So that implies like MVPs, experimentation. Experimentation, maybe testing. We have an agile software development, so we have sprints of 1 or 2 weeks. So what this means that is the pace of developing is really fast, and it looks for removing like delays and wastes of time. So we have a model that is, we call it like you build it and you run it. What it means that the squad owns the project and their service, and they deploy the service to production by themselves. So they have ownership and responsibility for it. This allows us to go really fast, and we deliver in production directly. This quote is like the changes that we do, the quote down there, the changes that we do in production in a day, like that's the motto of the company. So what this means is, again, the squads have really decentralized decision making, and we go really fast, and they embrace new technologies, and they fail, they learn, and they fail again, and they improve the product. So, why this context is so important, these 2 slides before, because this is like a traditional security team feels in this model. So this is the security guy trying to chase all the squads and the work that they do. So security doesn't care about being fast or delivering fast. What a security team wants is to do things right and audit everything and that everything is secure. So with the model that I explained before, what happens is that if you work like a traditional security team, it's like you are overwhelmed by all the speed of changes that we have, the number of squads, number of services. So it's really difficult to keep up with everything. So if you work like a traditional security team, what happens is you slow down the continuous delivery. So you cannot work like that. In fact, it doesn't scale, it doesn't work. So what happens with that is like security has to change the culture. Security has to shift left. What that means is that it must fit in how we work, how engineers work. It has to go to the automated pipeline, to the automated cycles. It has to be embedded in the tools. It has to be earlier in the design, in the code. So, I mean, you cannot wait for a service, a project to finish and then do a pen test or things like that, because when you do that, the service has already changed. So it's impossible. So, as I said, the squad model embraces autonomy and fast pace, and you build your running model. So the danger with that is like without the right supporting tools and standards, you can end up having developers doing their own things, like doing their own supporting tools like logging, metrics, health checks. So instead of doing working on their business logic for their service, what they are doing is wasting time reinventing the wheel, kind of doing the same things over and over again. So to avoid that, what we provide them is like standards and tooling and the common functionality for everyone. So you don't find like squads saying that we are developing in Python, the other squad is developing in Ruby, the other one is developing in Haskell. So imagine the mess that would be. So we have to, although there is like really an open culture and you can do kind of what you think is better for your service, still we have standards and common functionality for everyone. So I'm part of product security down there in this schema. So, and this is the developer enablement tribe. What the mission of this tribe, I'm going to read it because I never remember, is enable Skyscanner engineers to deliver secure, resilient, and efficient services at scale. So what we do is basically focus on all the software delivery journey. So from tooling, libraries, pipeline, some environment, and so on, and security in all of that. So what we try is to make engineers really easy to create production services well, ready production services in an easy way, basically. So what is CI/CD pipeline? Well, CI/CD pipeline covers all the aspects of the software development lifecycle. So from coding to building to testing to releasing to deploying. Even it covers even the monitoring or the operating side of it, like. And what is a pipeline better than a manual workflow? Well, the pipeline allows us to go really fast, but it allows to get really fast, but with confidence. So that's really important due to the model that we embrace. So how does that? We have testing, and everything is automated. We have so all these steps in the pipeline ensure that quality of the service is enforced. So we work with GitLab as our source repository, Drone for automating build and testing, Docker for having the same image and package across different environments. We use Artifactory for a package repository, like the libraries and things like that. And then Slingshot is the deployment tool. It is an in-house development, and it allows us to deploy services in AWS. So this is like a developer in a Skyscanner, and it's about to write a service. So that the end goal is to have like a GitLab repository. So I talk about how the dev tribe tries to make things easy for the developers. So this is like a clear example of this. So how a developer from no effort, from having zero, ends up having a GitLab repository and a service ready to be deployed in production. So what we use for this is Cookie Cutter. Cookie Cutter is an open source project that creates projects based on templates. So we provide templates for the languages that we support, Python, Java, and Node. And then we have MShell, which is microservice shell. So these are all the components that Skyscanner develops for metrics, login, health checks, A/B testing, and so on. And also some third-party libraries as well. Then we use Docker, as I said. But the good thing about this is we have like some base images for Python and Java Node. So we support those images, we maintain those images, we update them. And so with this, with only you go to the shell of command line shell of your laptop, and you say cookie cut me this Python project, and you end up with a GitLab project that is ready to go to production. So this is an example how this reduces adoption friction, right? So why are you going to develop in Haskell or some other languages if we provide all of this for you, and you don't have to worry about coding your own login or your own stuff for your service. So why this is good for security? Well, because we wire security checks in these templates. So you have the template for whatever service you are using, for whatever language you are using, and then we put stuff in the template. So in this example, well, no, doesn't work. You have the drone configuration, and we are writing in the drone configuration SonarQube step. SonarQube is the static analysis tool that we use. And we are using an official Skyscanner supported image. This is for Node. And yeah, so the developer, without noticing, is using all our security checks from the very beginning. So this is really good for us. So now, coming back to the pipeline, we have, because we embed these security checks in the cookie cutter templates, we have injected security into the pipeline. So we have SonarQube for static analysis. We have Claire for scanning Docker images. We have Sneak for scanning libraries. And SonarQube is a good example of cross-squad collaboration. This project was started by another squad, but they were more focused on code quality, code smells, and things like that. But we had some security rules for secrets, and we kind of used their work for our own benefit. So this is a nice example of cross-collaboration between the squads. Okay, so this is an example of what a developer sees when does a merge request in GitLab and the Sneak check fails. So there you see the cross, like security Sneak is failing. This is because the libraries that you are using have a vulnerability. And then there is the button of accept merge request, but it's in red. You can still accept the merge request. I mean, we are not gating anything, but you are deploying code and libraries with vulnerabilities to our environment. Well, this is the Sneak portal. You can get more information about the particular issues that you have in your libraries. So you can fix them or change them or update them. This is an IDE. To be honest, I don't know which one. But this is a good example of security shifting left. So here, SonarQube scanned the project, but it has the ability to raise issues while you are coding. So here, there is a message. It's not a security issue. That's the best picture that I could get. It was already there, so I got this one. So, but the idea is that SonarQube is alerting you about a problem. Well, the particular issue is that you have to use capital letters for your method names. This is more a code smell thing, or code quality. But the good thing about this is, like, the developer, while he's coding, he has feedback about security and about code quality from the very beginning. And this is, again, a merge request. When a developer does a merge request with his new code, and what SonarQube does is comment into this merge request in the particular place where the code is vulnerable. In this case, there is a hard-coded secret, a password. And so you can review it there and act accordingly. Again, we don't block. You can still accept the merge request. So talking about blocking or not blocking, so this is like kind of quite a philosophical question. And different companies take different approaches. Why this is important? Because, I mean, if you start putting gates like code coverage or vulnerabilities and things like that, you're becoming a blocker in the pipeline, and you have the danger of becoming a blocker, and developers start getting really pissed off with you, and at some point they are going to work around you and do something so they can avoid you. So for example, all the drone steps that we are putting, they can be disabled. You can go to the drone configuration in your repository and delete that particular step. So the idea is to be an enabler, not like a blocker. So be transparent and blameless to the developers and increase security with that principles in mind. Also, no's are a finite resource, so if you are starting saying no all the time, as I said, teams get really pissed off. So secrets. What are secrets? Well, I guess everyone knows what's a secret, something that you cannot tell. In the context of a pipeline, secrets are all the credentials, passwords, API keys, and so on, and all the credentials that you need to deploy in production, really. Where you can find secrets? You can find secrets everywhere, in the code, hard-coded in the code, in the logs, even passed as parameters to whatever, lambdas or things like that. So why this is a problem? Okay, this is an example of ECS service in AWS. This is the AWS Console, and you have the container details here. So the arrow there points to the AWS credentials, the access key, and the secret key. So I guess you can understand why this is bad. In fact, this is a real example, and with this, we managed to go from, to escalate privileges from a normal developer to production admin. So how do we handle secrets? We store secrets in a central management place. This means that you, as a developer, go to this secret portal and you put your secret there. Your secret can only be accessible from your project and from your team members. And this works in a way that you only need to, in your repo, you only need to give a reference to the secret, and then your service in production, your service running in production, will go to the secret manager and ask for this reference and get the secret. So why this is good? Because you never have a clear text secrets anywhere. So secrets are a big problem. So it's really easy when you are a developer to hard code like API keys or things like that. And we spot those with SonarQube rules as well. But still, as I said, we have quite a big problem with this. So Oliver from our team came up with this idea, it's like a security, a badge in your GitLab repo. So these badges are in your GitLab page, and so it looks quite bad when you show your project to other person. Okay, so next slides are to put some context on what these security checks implies in workload for the security team. So these are like a slingshot metrics, stats about deploying, how many deploys happen in production, and workflows, and so on. So these some numbers to get an idea how many deploys happen every day. And then we have like 4,000 GitLab repos, so that's a lot. So lots of those repos are not really that important for us. We even have a project that tries to archive those repos. So when it checks the committers, the time when they commit, and things like that, to try to spot when a repo has been like not under developed development. So it tells you, it tries to archive the project so we can reduce this number of GitLab repos. This is an histogram of the service that we have in AWS in one region. So like 800 Docker images, like 600 something services, well, the other way around, like 80 clusters, and one region. So where I'm going with all of this is that, well, simple, plain simple, we need automation. I mean, we cannot keep up with all of this. So we need some automation in the security team, and we need developers to be involved in the security as well. So we have this tool called Talos. There is going to be a talk on Thursday about it. Basically, it's our main dashboard where all the results from the security tools are gathered together. So we have metrics, dashboards, and also all these things are like correlated with other stuff like DNS names, APIs open to the public, and things like that. So Talos is a great tool for us because it allows us to prioritize and focus our work. So what service or what project is important, what project is more vulnerable, what project needs to have a look from the security squad. This is a Slack message from our bot. So what it does is gets information from Talos and automatically sends a Slack message to the Slack channel of the project that the alert is, what the issue is about. And so this is an example of using deprecated Docker images. So we have new images for Node 6 or Node 8, and they are using an old one. So the idea is you have these buttons, and you give feedback. You can say that this project has been abandoned, or you accept this issue. And when you accept the issue, what happens is automatically a Jira card is created so we can track, and it goes to the workflow of fixing the issue. So this really helps us because it puts some responsibility into the developers and allows us to reduce the workload that we have. More on automation. This is how MShell keep their libraries up to date. For doing this, they use these nice tools called Surveyor, the guy in yellow, and CodeLeaf. So Surveyor, what it does is it gathers information about GitLab repos, and then it allows you to query this information. It might sound like a simple thing, but it's really cool because you can go to Surveyor and ask Surveyor, give me all the projects, all the GitLab repositories that use Python, or give me all the repositories that use this Docker image, or I don't know, things like that. Or give me the repositories that are deployed in production. And then we have CodeLeaf. CodeLeaf is what it makes is automatic merge requests. So combining all this cycle, this particular example is to update a Java library. So what it's doing is from GitLab, getting all the projects that are using Java from Surveyor, and then with CodeLeaf, you are updating the version of the library. So why this is cool for security? So this is another example of security using a tool that was started or done by another squad. So we use these two tools like Surveyor and CodeLeaf for updating our Docker images. So what we are doing here is asking AWS, querying AWS, what services are running in production. Then we have Surveyor, and we ask Surveyor about some information about these projects. And then we get the images, Docker images of these projects, and we scan them with Claire. And we put this in Talos, in the dashboard, and we have all the vulnerabilities of the images that we have in production. But we don't stop there. Next step is we monitor Docker and our registry for when an image is updated. So that means when someone creates another image, or when we update an image because it has vulnerabilities, we have semantic versions, so there is another version of the Docker image. So then we use CodeLeaf to update all the repositories that are using this particular image. So in the example here, you see like GitLab repository, well, in the Docker file, so that's the image that the service uses. So we are changing the version of the image. So why this is cool? Because when you do this merge request, when you accept it, then the pipeline is triggered, and it goes to our production environment, to AWS, and you have your Docker image updated. So this is like a complete cycle. So back again to the pipeline diagram that we have been talking about. We have quite a problem here. So how do we ensure that a repository belongs to a service, or that a developer is member of a project? So we don't use GitLab membership for this. In fact, in Skyscanner, GitLab membership is quite relaxed, so everyone can read other repositories. And it's really common that you end up like committing code to other repositories because there is a really strong cross-collaboration. And in fact, this has been a cultural shift for me. So normally in all the security teams that I've been working on, you normally raise issues, security issues, using a Jira card. You recommend the solution for that issue, and kind of you stop there. Depends how involved you are in the design, or in what phase of the project you are. But basically, you don't implement the fix by yourself. So in Skyscanner, you can end up, I've been committing fixes directly to other squad services. So what this means that people is forking and committing and doing merge requests to other squads repositories. So imagine that a malicious insider clones what forks a repo and triggers the pipeline and ends up deploying a service where he changes the code, doing some bad stuff, and deploys this new service in our infrastructure. So what happens here if you are replacing a good and legit service with the malicious service? So how we avoid this? We have these membership checks. So we map the repository to the service, and we map user to projects. So this cannot happen. So we are sure that the service that are deploying in our infrastructure belongs to the squad and to the repo that they are supposed to. So still we have some other issues. Drone is like a really open platform. Drone works like having pipeline steps. All the steps are drone plugins. Drone plugins are Docker images. And what happens is like squads historically have code their own drone plugins to make changes in the infrastructure. So for example, the Strat squad takes care of routing and APIs. It has a plugin that allows you to deploy an API into production. So why this is a problem? Because we have all the security checks that I mentioned in the slide before in Slingshot, but we don't have the security checks in the drone plugins that you are doing by yourself. So what happens here is these plugins act on your behalf, and then you can committing code and triggering the pipeline, you can change the infrastructure. So that's quite bad. So the idea is to move all these drone plugins to the other box there, and that all of them go through a slingshot. This is still in the process. Okay, so far I've been talking about how we deploy services in AWS through the pipeline, but a service needs a lot more of stuff to work. A service interacts with databases, with S3 buckets, with dashboards, with a lot of different things in AWS. So we need a way to provision all these service, all these resources for the service. So traditionally and historically, there was what it was called the ambassadors. Ambassador was quite of an Amazon admin, and he was deploying or creating these resources on behalf of the developers. So why this is bad? Because we have like people being admin in AWS. That is not ideal. They can make mistakes, or they can use these permissions to do malicious stuff. So we did this change that now developers use CloudFormation, and developer goes to the AWS Console and they deploy a CloudFormation. So you have your stack, and the stack has as code all the resources that it needs, and it deploys all of this to production. Still, this is not ideal. Why is not ideal? Because we don't have a strict control what a developer puts in this CloudFormation template. So what can go wrong here? So I'm going to give a specific example. So this is some news about S3 buckets, insecure S3 buckets. S3 bucket is Amazon simple storage service. So basically, it's like a bucket where you put some data, and it allows you to store information. So if you don't do validation of the things that you put in AWS, you can end up with these problems, like a S3 bucket open to the wall, and this is really common. And so yeah, this is an example of why that's bad. So the next step is infrastructure as a code. So the idea is to have another step in the pipeline. You have your CloudFormation in your repo. You don't go to the AWS Console. And the pipeline takes care of deploying all the infrastructure that you need, all the resources that you have in your stack. So again, why this is good for us? Because now we can add a step in the pipeline and do some validation and linting of the AWS resources that you are putting there. So we are using CFNAC. CFNAC looks for insecure patterns in your CloudFormation, like the S3 bucket example, or security groups open to the wall, and so on. So this is an example of the output of CFNAC validating, or the results of validating a CloudFormation. So I don't know, this is a real example. This is a project from the security squad. So we had like a password in the CloudFormation, so talking about secrets. So I mean, this is really easy to miss. I mean, when you are deploying stuff, you don't care about these things. So it's not a blame culture at all. It's like it happens. So we need to validate what we put in our environment. Infrastructure as a code also helps us to improve our controls in the infrastructure. So this is how we work now. We have two accounts. We have the development account and the production account. So the dev account is for testing or kind of playing around. And so when you want to go to production, you have to assume another role in production. So you have STS like with temporary credentials, and you go from your dev account to production. And we have this for all the projects that you belong to. So if you are part of a project, you are allowed to get the role of this project and change or go to the console and check on the resources that this project has. So why this is dangerous is because normally dev environments have more relaxed permissions, and as I said, it's easy to think that it's like a playground, but it isn't. And this is some IAM actions that are allowed by default in this dev environment. This is not there anymore, but it was at some point. So what can you do with this? So the third one is like change a role policy. So we have all this nice infrastructure as a code, all this CloudFormation validating and all this stuff, but what happens if you can go to your dev account and change a role that you have deployed? So you are bypassing all the checks that we had before. So in this example, using the put role policy action, what I've done there is star policy. Star means that you have access to all the resources and you can do whatever you want in those resources. So then you go and use the put role policy and you embed this policy into a role. So I said before, for going from development environment to production, you assume a role. So production and development environments, they have these trust relationships. So you have a role in production that allows developers to assume. And this is a two-way thing. So you have to allow your role in development environment to assume that role, and the role in prod has to allow as well. So it's like two-way. But if you are able to change the role policy and you put star, and also you have a role with this in the principal, you have this 1, 2, 3, 4, 6. Well, that's the way that Amazon identifies resources and users and everything. So here what you are saying is that you are allowing not the root account, you are allowing all the users or roles in the root, in the development account, so everyone to assume this role. What that means is like if you have that star policy and you have a role in production like that, that is allowing everyone from the dev environment to assume that role, then you can escalate privileges and assume the role. So you were a developer with developer permissions in the development environment, and then now you are in production. So this is the AWS Console, and why the infrastructure as a code will allow us to restrict better access to this is because you have all this pipeline where you can have a file in your repo and repository to provision your service. You don't need access to this anymore. So we are like changing, we're stopping, blocking another attack surface. So this is the end goal that we have with the infrastructure as a code project. That is that any change in production goes through here. So you don't need access to the console anymore. So all of these problems within cross-account relationships and assuming roles kind of go away. And well, thank you for listening. Yeah. Do you have any questions?
Hi. Hello. You said you use some tool for storing secrets.
Mm-hmm.
What tool do you use?
Well, it's an in-house development, but what is using underneath is KMS. It is Amazon KMS, basically.
We recently started using HashiCorp.
Bold, yeah. Yeah. It's a great tool. So we are now going to Kubernetes. That's our next orchestration project, and we are also looking into Bold. So we might end up using Bold instead of our solution.